Welcome back. So yeah, we've talked a little bit about getting set up. We've talked about some of the pitfalls and what things are missing right now.
Yep.
Some ways you could deal with that. We're going to go a little bit further into how to deal with this dual runtime environment that you're going to bump into. So for this module, that's what we're going to really sink our teeth into.
Yep.
So the overview for this module is obviously we're going to look at working with Mono and the .NET runtimes. We'll talk about how to use compiler directives to kind of help with this. We'll look at how you can check your plugins, because I found that a lot of times it's plugins that'll really trip you up. So we'll take a look at how you can deal with that, and even a little tool that you can use to help you with that.
Yeah, and I mean that's not unexpected. The plugins are written by third party. They're not necessarily written for your game or with porting to whatever you think you're going to go to, right? So that's a common catch for people.
Yeah, a few of them are like written mostly just for that platform,
That's right? Yeah.
So there is some issues around that. So we'll take a look at how you can check that out and maybe deal with that as well. Right. And also we're going to look at a simple way to build a direct connection between our Unity code and our Visual Studio code.
Yeah, which will be very handy.
Yes.
As you'll see.
Yeah, yes, it'll definitely come handy in future modules for us. So let's jump right in here and we'll take a look at runtime differences. So when running your game, I stated this before, but it's worth stating again, that when running your game with Unity, it's going to run in the Mono runtime. And that's because Unity's built using the Mono APIs.
That's right, yeah.
So yeah, you'll bump into this is the dual runtime. When we mean dual runtime, we mean that Unity's running in Mono and our platform-specific builds are running on the .NET subsets.
Right, so you're going to have both going, and there's some communication situations that can come up and how to talk back and forth between them.
Exactly.
That's what we have to address.
Yeah. So again, when you deploy to the Windows Phone or Windows Store, it's going to run using this .NET runtime. For the Windows Store, again, it's the .NET Core profile, which is it's a subset, so it means it doesn't have the full .NET implementation. And for the Windows Phone, it's actually running against the .NET for Windows Phone. Again, a subset without the full features of .NET.
Right, and both of them are slightly different from each other.
Slightly different, yes.
They're not the same subset, obviously. They're optimized for the two different platforms, really, that they're supposed to be running on.
Exactly. Okay, so some of the popular classes that you might be missing in the system collections, because a lot of us use the system collections namespace, is you're missing again, and I want to state this just one more time, that this is accurate as of time of writing. Check it. Yeah. Make sure you double check it. Always verify this information.
Worst comes to worst, you can just try it, and when it fails, then you know.
And that's one way of going about it, yes. Yep. So yeah, things like the hash table are missing right now.
Yes.
The array list, ordered dictionary, the sorted list, as well as the queue, stack, and a few others are missing as well. But these are the main ones that you're probably going to bump into when you're building your games, and you may have used in your games, and you might have the issues with.
Now, some of these are a little bit less common than others, so it's not a big deal for a lot of people. I know some people really like to use the array list, and that's fine. As far as I'm concerned, there's other ones out there that you could be using that are a bit better. But
personal preference, yes.
Personal preference, yeah, sure.
Okay, yeah. So just dig into that. Make sure that if you are using any of those, there are workarounds available online, and of course, like you said, there's other ways to do pretty much everything in this list.
That's right.
Some of the runtime differences that you're going to bump into is around the file IPOs. Or I/O IPOs, file I/O APIs. There we go. But the programming model, the reason for this is it's asynchronous, and the namespaces are a little different. So that's why you're going to bump into some of these issues. So you're not going to find a few classes in the system I/O that you might be expecting. Some of the frequent ones that you're going to be looking at and are probably wanting to use are the system.io.file, your system.io.streamreader, and your system.io directory. So if you're using these, again, there are ways to get around this. There are other things that you could do. You could maybe just implement it yourself like we were saying before. But yeah, you're definitely going to want to look at other options if these are ones that you're using. As well as, the Unity Engine.Windows namespace has some basic I/O implementation of its own. So the ones that we generally need for games, they may be in that namespace. So that's definitely something you want to check out if you're using system.io namespace and having these issues. You can definitely check that one. Sorry again. Here are a few tips that we're going to talk to you about, with dealing with this dual runtime environment, things that you can kind of do to mitigate this issue. One of them, right off the bat, is the preprocessor directives. To refer to this, basically you use certain types of if statements inside of your code.
Right, and these are preprocessor, so they happen before really the compiler gets through building your game and running it and everything like that. So it's a way to say, only include this if I'm on this platform and so on. It's one way to handle those kinds of situations. Mm-hmm. Yeah.
So for the Windows Phone side of it, you're going to want to use the #if Unity _WP8.
That's right.
And if you're using the Windows Store side of it, you're going to use the
if pound Unity Metro, which Unity has decided to be for Windows Store. So
yes, exactly.
Unity has decided these are the names that they're going to be used. They put them in there, and that's how we differentiate our code from different pieces.
Mm-hmm. So again, if you want to build something that inside the editor or code that you only want to run on the Windows Phone or Windows Store, this is how you're going to make the compiler know that this is only to be ran on these platforms specifically and not just in the editor or any other platform for that matter. Another thing that you're going to bump into is when you're using plugins, right? So we'll talk a little bit about how you can structure the plugins. So if it's a Unity editor plugin, you're going to want to stick that, of course, in the assets/plugins. So a lot of us are used to that, right? If you're using an editor plugin, that's basically where you're going to want to place those. Now, if you're using runtime plugins that are specific to the platform,
they go in the editor folder, assets editor. Well, it depends, I guess.
It depends on the plugin.
For plugins, yes, but for scripts,
for the editor, it goes in. Yes, you're right about
assets editor, right?
Yes, exactly. So yeah, for the plugins though, you're going to want to put it in the plugins folder, which kind of makes sense, right?
Yes. Sorry.
Yeah, no worries. So the runtime plugins, they're going to go into their own separate folders, right? So if you got a runtime plugin that only runs on, say, the Windows Phone, you're going to want to put that inside of the assets/plugins/WP8 folder. If you've got something that's running on the Windows Store side of it, you're going to want to put that in the assets/plugins/Metro. So yeah, that's one way you can deal with keeping these plugins separate so that when they're running, they're only running on that specific platform, right? And the editor knows to look for it in that folder as opposed to looking for it in the plugins folder.
And again, those are the names Unity has chosen, sort of like they chose all the scripts need to be in the editor folder and so on. It's something the editor itself, as a tool, goes and looks for those named folders to pull those things in.
Exactly. Now, if you've got native plugins, so native plugins are native to the specific architecture. So if you've got plugins, say, for something like the x86 or the ARM plugins, they're going to go in their own separate folders. So for instance, for the x86, it's assets/plugins/metro/x86. That's a mouthful. For the ARM processor, it's going to go in assets/plugins/metro/ARM. And so this, again, allows the editor to know, okay, I'm only going to use these plugins if I'm building or using it for this platform and this architecture specifically. So that's how you get around having native-only plugins.
That's right.
Mm-hmm. And of course, one of the biggest things that we can mention is test your game thoroughly. I can't stress that enough. You've got to test it on the device. It's the best way to know if it's working properly is to pop out the device, load up the build, and play through it, right? You got to try and break it to know if it works.
Yeah, as often as you can. As soon as you have a piece that you know is now runnable, you test it, put some more in, test it, put some more in, test it again. Let's just cut over here, and I'll show you those preprocessor flags, just in case some people aren't used to using them. I have them in the code base. This is in our Windows Gateway file.
Can you zoom in on a little bit for that? Make it easier for them to read.
That's right. There we go. So, for example, here's one, if Unity WinRT. And this entire class, effectively, is going to be inside this preprocessor if, all the way down at the bottom. There's our end if, and that's how we can open and close something that we want to be included when specifically we're building a build through Unity for this technology or platform or whatever it's going to signify. Now, you can also do this with your own code. Unity has your support for making your own defines here that you can do, and then you can put it into the build as a switch or whatever, and it will enable a bunch of code. So you could do that for debug code if you wanted, as well as not just platform-specific code.
And this keeps it nice so that way you're not writing a bunch of extra classes for each specific platform.
Right, and that, typically that was another approach. Sometimes you'll have your Windows Gateway class for phone or something, and people will make 3 or 4 classes that do the exact same thing but handle it on a different platform. Sometimes that is a nicer way to do it when it's literally the entire thing that's going to change. But sometimes, for example, here, I mean, really we have one line of code that's different just for the Windows Store platform than everything else in the Windows RT general change for all the other parts of the Windows platform. So there's no point in rewriting this whole class just when I want to add one line, right?
Yeah.
So we might as well just put it in with this nice little preprocessor flag to switch it in or out as the compiler decides when we build the build, if it needs it or not. And really that's all these are for. Again, you can see here's another function that we've basically added when we're in that form or not. So detecting whether or not the window size has changed, and if it is, we'll pause or not if the width is less than 500. So just something to demonstrate for those who haven't seen how to use a preprocessor command. Of course, this code effectively gets stripped out. If I'm not on this platform, all of this code wouldn't even be considered by the compiler. It would be removed from the build. It does shrink your build size down marginally. Obviously, text doesn't take up much space in terms of code binary, and so it gets removed out of there. But it's something for people to be aware of that you can use as you're porting or as you're building for multiple platforms and so on to keep all of your platforms separate and the different controls you need.
Yeah. Yeah, so it's definitely a good tool so that you can save yourself a little bit of time, right, when you're building. Yeah. And you don't have to build out tons of classes and tons of different,
And it's good as doing the porting process. It's good to have that ability just to test chunks by basically enabling it or disabling it as you go with those preprocessor commands. You can just, I want to see if this next section will work fine. Oh, no, it didn't. There's a string format command in there that I didn't see in my large chunk of code. I should now, remove that preprocessor, fix it properly, and put 2 chunks, one that handles it when I'm pushing the phone, one that handles it when I'm pushing to some other phone.
Yeah, or say you wanted to maybe display a message or something in your debug, right? So you want to see, how far is the player moved on the screen or something like that. You could use this preprocessor directive to only show it when you're debugging. Right.
That's right.
So yeah, it's got a lot of uses just outside of just what we explained.
Right,
there.
Not just with porting, but as a whole, it can be useful for doing various things during development. Even optimizations, for example. Sometimes when you're code profiling, is this better? Because I'm pushing to a platform that has less power. I need to get some optimizations in there so that I can get some frames per second back or something so it plays well. Sometimes you can just go in, you can find the part of code that's slowing you down with a profiler in the editor, find what you're spending your most time on, wrap that in a preprocessor block so that that chunk of code doesn't get put into your version, and then put what you think is going to be your optimized version of that same functionality or mechanic or whatever, write it and put it in its own preprocessor block for that platform, and now you can see the timing differences, see if you did a better job or not, or if it accidentally makes it slower because it affects something else later on down the pipeline that messes it up, and so on and so on. So it's good for debugging processes, it's great for optimization processes, and it allows you to do sort of these smaller switches when you just need 1 or 2 lines of code to be swapped out going to a different platform.
Yeah. It's a very handy tool, that's for sure. Okay, so I'd mentioned a little bit before that some of the major issues that you're going to bump into is around plugins. The one great thing about Unity is the fact that they have the asset store, and you can download a lot of these plugins to help you when you're building, so you don't have to reinvent the wheel, so to speak, right? You've got a lot of options available through the asset store. But again, this is going to cause an issue when you go to port, because a lot of these plugins are supporting specific platforms, or maybe are using not using .NET implementation, they're using a mono implementation, and that's going to cause an issue when you actually go to port to the Windows Phone or Windows Store.
Right, because some of these plugins, you got to remember, Unity started out as a web player version, right, and engine and sort of like that as their, a way to make games other than Flash and that kind of stuff. And so a lot of the tool makers or the store asset creators also come from different backgrounds where they haven't ever needed to worry about porting to any platform because they only work on the internet, and the internet's the internet. The only thing they had to worry about was different browsers.
Exactly.
Which is why you wanted to use a player anyways, because if they had the player, you're good, right?
Yeah.
So if it had the Unity player, my game will work. I don't care what browser it is, kind of deal, right? So that they are working from that kind of mindset. So they're not even considering things like this. So if you are an asset developer and you are out there, then maybe you want to start considering these kinds of approaches when you go to build things. Make sure that it's more generic in code and stuff like that, so that it will work on other people's stuff. Or when you provide them that source code again, it's easy for them to tweak the 2 or 3 things that they need to get it. And then, of course, you can ask for that sharing of the communication back so that you can make your tool better for everybody as well, to support all of these platforms that continually come out and evolve as we go. So it's good not just for people doing the actual porting, but you want to keep that in mind if you are an asset developer rolling out the items for people. It gives you a broader base now of who you can sell your assets to and what they can move their game to.
Yeah, definitely. So yeah, one of the ways that you can deal with this, or at least it helps a little bit, is if you've got a plugin that's been shipped as source code. So something like the very popular NGUI plugin. If they ship it via code, your compiler will actually catch a lot of these issues for you before you go to deploy to the specific platform. So one thing you could do is maybe dig into the code and change it yourself, or of course you could message the creator of the asset plugin and let them know that you found this issue and ask them if they could maybe help you in support.
Yeah, with some support, because again, it opens it up for them, right?
Yeah, and it lets them know that other people are probably going to bump into that issue as well, right? So it's nice feedback for the asset creators as well. Now, if you have a plugin that's shipped as binary, chances are you're not going to see the error until you actually do a runtime push. So when you're actually running it on the platform, you're going to bump into it then, right? Or when you try to load it or use it, that's when it's actually going to throw these errors. Now, we've actually found a fun little tool that helps with this. It's actually on the Xamarin site at scan.xamarin.com. It's the link down there on the bottom. I forgot to hyperlink it, but I'm sure you guys can copy and paste that. So I'm going to actually jump out and I'll show you the tool real quick and show you how it kind of helps. So I'm here at the Xamarin website, and you see I've got the scan.xamarin.com, and this is the actual tool. So what you can do with this tool is you can upload a compiled executable, or you can upload a dynamic link library, and you can actually test it to see what platforms, if it's using .NET libraries, right in this tool. So it's very helpful, not just for the Windows Phone and Windows Store platform, but it's actually going to tell you, does this work on Android and iOS as well? So it's a very, very useful tool. And of course, you can actually save the name of the scan, and then do a little bit of other stuff there at the bottom. But I found that this tool is really useful if you've got a precompiled plugin that you want to use.
That's right. Yep, it'll work out.
Yeah, so definitely, if you've got a lot of plugins in there and they're all in binary format, this is probably your best first step anyway.
Yeah, it's a great first step as a pass just to see what's going to happen.
Yeah, exactly. So that's just that site there. I'm going to jump back into our slide deck here. So yeah, that talks. We talked a little bit about the plugins and stuff. Obviously, it's a piecemeal approach. You have to check each one, right?
Yes.
That you're working with. It's not a magic bullet to solve the issue, but as you're digging through the plugins that you're using, these are some of the issues that are going to arise.
And again, you're going to take that piecewise approach anyways, because you want to check one, get it in, get it running, get it working, check the next one, and so on anyway, so it's not that big. It's part of what you're going to be doing as your process anyways, if you even need to. A lot of games that I develop don't require any plugins, but I mean, I have a lot more software design background than most people, so I like to build all that stuff out and do it myself. But there are other games where they only use 1 or 2 plugins because that's their main mechanic. They needed that plugin, and then they're good. So it probably won't be a lot of legwork for most people. And if you do have a massive game, then you probably have a massive team also. So you have more people to help you port it and get it out there anyway. So it shouldn't be too much of a problem. But it is nice that that tool is there to do that cursory check.
And and if it's the case where it's just that version of the plugin, obviously check the websites by the creator of the plugin. They might have done an update already, so don't be completely discouraged if it doesn't run .NET right out of the box.
That's right. There may have been an update that you didn't even check for because you've been using it for the last, I don't know, 6 months with it on some other store, and now they've already supported that. So make sure you do verify from the vendors themselves that they do or do not have an updated version.
Okay, so let's talk a little bit about building a connection between our Unity and our Visual Studio project. And by connection, I mean, you've got this XAML code that's basically like, I like to refer to it as like kind of like the box around your code, right? It's the presentation layer, if you will, that helps, do some simple presentation things. And you want to be able to pass data between that and that thread and your Unity game thread, right? You want to be able to pass that data back and forth. And this is important because when we do things later on in the share, right, we're going to have to pass data back and forth. When we extend the splash screen, this is going to become very important.
That's right.
Because we need to be able to tell what's going on inside of Unity, inside of our XAML code. So one of the simplest ways to do this is through the direct communication approach. Right, you're running .NET on both sides, on your Unity scripts and the host process. So creating this direct connection makes sense. Right now, we're going to show you the direct communications approach. There is other ways to do this. You could build a plugin system that'll allow you to talk back and forth. But we wanted to focus on the easier way of doing it. Just to help you get a leg up on this, if you will. Down the road you might want to take a look at maybe doing a more advanced implementation.
This approach is a little bit easier for people to get their feet wet with because it is direct. It is more direct. You don't have to worry about learning how to make a plugin because some people don't know how to develop a plugin. They've never bothered doing that before. They only purchase plugins and use them, not create them themselves. And also even to build your own plugins, you actually need I believe you need the higher version of Unity as well.
I think you do need Pro, yes.
So if you're working with the free version, then the direct approach is going to be much easier for you to port over anyways until you have your money from all of your wonderful sales to go and get yourself the Pro version.
Yes. So for example, what we've done is we've created this class that you can actually find in the assets script/windowsgateway.cs. And this class is actually going to provide us with this communication that we can use between the Windows Store and Unity. Again, this technique is a very, very simple technique to do it, but it does come with the drawback that it's limited in regards to the types of communications that you can actually expose with it. So if you're looking for something, again, a little more robust, maybe there's some certain things that you need to do, you might have to go the plugin route.
That's right.
So here's a little snippet of code, and after this I'll let you walk them through the actual content, but this will just give you a kind of an overview of it. So what we do in the Windows Gateway class is we expose an action. And now an action is a void delegate with no parameters. So if you look down here at the code, Unity is assigned or equals delegate, and it's blank. The reason that it's blank is it's so that we can avoid some errors inside of Unity's editor. And this basically sets up the framework for us. And then down a little bit lower, you'll see public static action Unity loaded, and that's the actual setup for the action. So then when we go into our Visual Studio code, we can basically just call that code directly. We can say Windows Gateway.Unity loaded, and assign it a function that'll get launched when that action occurs. So it's a lot like an event handler.
Right.
Right? So you're setting it up, and you're setting it up to basically listen for this action, the action fires, and you're going to launch this code that's inside of your handler function, if you will. So why don't you go ahead and fire that up, and we'll do a quick overview of the direct connection class.
Okay, so in Unity here, in our little sumo block game, once we get there we go, we have this Windows Gateway script, of course. And if I pop that open, I'll just bring it over in mono. It's a basic static class that we have set up, and you can see again we got those preprocessor commands in here taking out certain pieces. For example, we do want to handle sizes being changed in 4.3.
Yeah, we're going to talk a little bit about that in the next module as well.
We'll look at that, and you can see that we're including effectively a handler there. Here are those blank delegates that you were talking about, so we can detect when Unity is loaded or when we need to share a high score. And we're stubbing them in just as blank delegates to avoid any errors within the editor. You know, you don't want extra warnings and errors clogging up your display, even though you know you don't need to care about them.
Yes.
So we've just stubbed them in so that those go away and everything's hunky-dory, and we can continue on. So the actions, here they are here, those same actions that match those delegates. So we have Unity load as a static action, and we have share high score as a static action, so that we can get a hold of them whenever we need to from the Visual Studio side of things.
Yeah, and when we jump into when we do our next segment, we're going to show you how to build the actual Windows Store Visual Studio solution, and then we'll dig into that and show you where we're actually hooking that up to that action.
Right, and that's really all there is to it. It's just a basic class. It's static, and it has those delegates, and that's really all there is to it.
Yeah, it's not very complicated, as you can see. It's pretty simple to get this direct communication working between the two. Right. And which is a good thing, right? You don't want it to be overly complicated. You want this to be smooth and seamless.
As effortless as possible.
Exactly, right? And that's the beauty of this, is it's very effortless.
That's right. You can go in there, add as many as you want, as many actions as you need to talk back and forth, depending on what you want to do with your live tiles and share contracts and so on, which you'll see us play around with in a bit.
Yeah, exactly. So do we got any good questions popping up in the chat there?
Let's see, what do we got right now? Some general query stuff that is just having trouble running something, so we don't need to address that one here. I don't see any at the moment that haven't already been answered by some of our support team or somebody.
They're doing an awesome job staying on top of all those questions for us.
Cheers to those people. No, I think that's it for right now, but if another one comes up, we can always address it after the break.
Okay, sounds good. So why don't we take a quick 10-minute break, and when we come back, we'll talk about supporting Windows 8.1, and we'll look at some of the cool things that you can do inside of there.
Sounds good.